The topic today is power. So, as a store manager, would you prefer to hire a clerk who would unload a truck in 1 hour or a second clerk that could unload a truck in half an hour? Well, if I was the store manager, I would want that person that could unload it in half an hour. So, if the employees did the same amount of work, though, unloading the truck, what was the difference? Time. Okay, that other clerk was able to finish it in half the time that the first clerk could. And so time is very important in power. So power is the rate at which work is done. So how fast or slow work is done. So watt is the unit for power. So hopefully you remember that the unit for power is watt. And just think of J.J. Watt from the Texans. So 1 watt is equal to 1 joule of work done in 1 second. So let's see what that means. So the formula for power is work over time, work divided by time. So remember, power is in watts, and watts is represented by capital W. Work is in joules, represented by capital J, and time, lowercase t, is in seconds. Okay. In our previous lecture about work, we learned that work is equal to force times distance. Okay, so if W equals FD, then we can plug this in to here. So that gives you this equation right here. Power equals force times distance over time. This is the same, this and this is the same thing. Okay, if P equals F times D over T, then, okay, stay with me here, P is equal to F times velocity. Do you remember the formula for velocity? Velocity is distance over time. So if we take this equation, you can see right here, this is equal to velocity. So that's why we can say P is equal to F times V. So when we think of the word power, you have to think about the time it takes to do work and the energy used to do that. So James Watt was a Scottish engineer who invented the steam engine. And so to have a unit for engine power, we call that the horsepower, or we still call it horsepower. And so at the time, Watt expressed the power of his engines as the number of horses an engine could replace. So through experimentation, we figured out that 1 horsepower is equal to 746 watts. So who has more power here? So on the left, we have Michael. He has a force of 100 newtons and a distance of 2 meters and a time of 1 second. As opposed to Jim, Jim also has the same force and the same distance. So remember, work is equal to force times distance. So let's see who we see here that they do the same amount of work. And that makes sense because they both do 100 times 2. Just so you can see why they do the same amount of work. They both do the same amount of work, but the only difference here is time, just like we said in the beginning. So power is work over time, or remember, power is also equal to force times distance, because force times distance is work over time. So this is what we're using here. So force times distance over time. So the time here for Michael is 1 second. So 100 times 2 is 200 divided by 1, 200 watts on the left. As opposed to Jim, same amount of work, but divided by 10 seconds, that's going to give me a lower power. So this is why Michael on the left here wins and has more power. So let's say a motor does 5,000 joules of work. So capital W equals 5,000 joules in 20 seconds. So T is equal to 20 seconds. What is the power of the motor? P is equal to, okay. So when we're doing these type of problems, you want to write down your variables first and then put a question mark on the variable that we do not know. Okay, so power is just work over time. And so this one is simple. Our work was 5,000 joules divided by 20 seconds. That gives us 250 watts. So a machine does 1,500 joules of work. So again, write your variables first. Work is 1,500 joules. And time is in 30 seconds. What is the power of this machine? So again, power is work over time. So we have 1,500 joules divided by 30 seconds. That gives me 50 watts. That's how much power we have.